Hello scholars, welcome back. Mr. Hinkle here. Happy to talk about something that I love, which is the moon. I look up at the night sky, sometimes there it is, boom! My favorite thing is when I'm hiking in the forest in the middle of the night on some adventure and I come around a corner and it almost knocks me off my feet because there's the moon on the horizon. It's so big. I'm like, whoa! That is awesome. And since that's so awesome, let's talk about where the moon came from. What the heck? So we will talk about the impact theory of moon formation. We'll analyze just a few characteristics of the moon. This is a brief introduction. So the moon is Earth's only natural satellite. It's the 5th largest moon in the entire solar system. So it's a fairly good sized moon. Jupiter has tons of moons. It's got some pretty big ones, but hey, our own moon, it's up there in that top 5. Let's go. People have been fascinated for so long. The moon has influenced cultures. There's a lunar calendar. This is how important the moon is. And it's been a hot topic of scientific inquiry, wondering the question, how did we get a moon? Where did our moon come from? Well, let's talk about that. So, the giant impact hypothesis of moon formation. Early Earth, 4.6 billion years ago. The solar system is just about born. You know, it's been going through the stages of solar nebula, protoplanetary disk, protosun, planetesimals, and all of a sudden it's feeling good. The planets are all out here, and the idea is like this. Earth is a big, hot, homogeneous ball of material. All these planets are material that would soon cool to become rocky and make its structure today. But then there's another planet called Theia. I did this a little bit wrong. It's about a third of the size of Earth, maybe about the size of Mars, right? A third of Earth. And while our solar system is figuring itself out, about to be born, Theia actually collides with the Earth. Their cores fuse together and they shoot a bunch of debris out into space. Right? So now we've got, here's the next stage, we've got Earth that's fused with Theia and all this material in Earth's orbit. Well, the Earth is spinning, the material collects in the disk, and just like planetesimals clear their orbit and become planets, the debris around Earth clears its orbit, and it becomes our moon. And so what's left, let's go one more, is, when I do another color for us, is what we have today, Earth and moon, forever walking hand in hand in lockstep because of our shared gravitational attraction. So cool, right? This is consistent with the moon having a proportionally smaller core than Earth's, a lower density than the Earth. Moon rocks are similar to Earth rocks, and so it makes sense that if we have the same type of material, well then, we probably were once the same. So, some stats. The moon is about, did I say? Oh, that was Theia. The moon, right, because we merged, is about a quarter of the size of Earth. But it's still big, 2,200 miles in diameter. It orbits Earth at a distance of about 240,000 miles. So the moon is 240,000 miles away. I love the moon, and I can't wait until we go back on the moon. I hope it's 2026. But at this time, every time I record these lectures, they're pushing it back, they're pushing it back. Let's go, NASA. Let's get on the moon. Let's get people. Let's get boots on the ground. Let's get a base going. Let's have scientists collecting research. Yeah, how cool is that? I can't wait. Anyways, when you look at the moon, there are two distinct features that pop out. There are highlands that are covered with craters, and there are lowlands that are very dark. And so what this is the lowlands are dark regions that have been covered with lava. And the highlands are densely cratered regions that haven't been filled in with basaltic lava when there used to be volcanoes on the moon, but the moon is so small it cooled relatively quickly. So there's no more there's no tectonics, there's no more volcanism. Now it's just a big rock in space. Let's see. The craters, yeah, okay. So the craters are from asteroids. 4.2 to about 3.9 billion years ago was a period called the Late Heavy Bombardment, when the Earth and the Moon were riddled with asteroid impacts. Some scientists believe that these asteroid impacts brought a lot of water to the Earth. Others believe that all the water was here. Nobody really knows, but there are definitely different hypotheses for where Earth got its water from. When you look up at the moon, you always see the same side, and this is because of what's called synchronous rotation. The moon orbits the Earth once every 28 days. That makes the lunar calendar. But it rotates at the same exact rate. So the dark side of the moon is the side of the moon that we cannot see. And the near-facing side is the side that we cannot see. We always see the same side of the moon because of synchronous rotation. That's kind of awesome. Kind of weird, but definitely more awesome. Okay, the moon is special. It's Earth's only satellite. Our best idea for the formation of the moon is that Theia, a Mars-sized solar system body in the early stages of our solar system, collided with Earth, shot a bunch of material into Earth's orbit. That material cleared its orbit, combining into the moon, which then got hit with asteroids, which triggered volcanism, creating two types of terrain: Maria, the dark lowlands, and the highlands. The highlands? Yeah, the highlands. I don't know why I just had to double check myself on that one. The highlands, which are the areas that aren't covered with lava and that are covered with craters. So the moon is awesome. Thank you so much. Can't wait to see you again. Have a great day.